review our parabola. Hey. We're going to review our parabola, and then we are going to begin the hyperbola. So, you just took a quiz over the ellipse. That's fresh in your mind. Let's back up a couple days and look at this. This is a parabola. How do we know it's a parabola?
1 squared.
1 squared. Very, very good. Now, for a parabola, the list of information starts with the vertex. There really isn't a center. There's a vertex, a turning point. So where's the vertex? At 3, -1. These are the ones we have to be very careful of the order, right? Does everybody understand why the 3 comes first? 3, -1. X is 3. Now, we need to know the rules. This is an x squared with a negative coefficient. What does x squared negative mean? Down. So this parabola opens down. Right? Now, the focus is always inside the parabola. So in this case, it's straight down from the vertex. This distance is called P. Since 4P is 4, P would be 1 or -1. It doesn't matter. The negative just tells me I go down. But I knew that already. So if I start at this point and go down 1, where will I be? 3, -2? And if I go up 1, I will be the line where y equals 0. Now, some of you said x equals 0. And I understand that. You saw the x-axis and said x equals 0. But you need to remember what Mrs. Ford told you. The axis that it crosses is the letter that it is. Which axis does that line cross? Y. So it's the line y equals 0. This is called the focal width. In this problem, what is the focal width? 4. A few of you still put -4. The width, the number is negative, absolutely. But the width must be a positive number, so we say 4. Yeah.
I just have a question, like on D, it's like wherever this, it's like root. It says root 2. At the original, like, is it just the opposite? Like, because that one's x is root 2, and then don't you just solve for y? Like, is that like a shortcut, or is that just a coincidence? Or you understand what I'm saying?
I have no idea. You're talking about root 2. I'm not getting that.
Squared, yeah, squared.
Oh, okay.
Like it says x squared, and then it'd be like then d would automatically be y, or is that just?
No, that will always happen.
Okay.
That will always happen. Yeah. Yeah. Okay, we all right with that? Now remember, probably on Wednesday we will take our hyperbola quiz. We might be ready for it tomorrow. Tomorrow, Wednesday, we take our hyperbola quiz. Then we're going to have a big quiz that has everything on it. All right, so you need to pay attention to this so that you remember it. Maya?
This is a little bit off topic, but it's still in the realm of math.
Okay.
You gonna have like a study session for our final?
I hope to.
Because remember when you did that and it was like at night, but still.
Yeah.
When we have a study session?
Yeah, I hope to. I hope to get one organized here. All right, here we go. We are now on note sheet, page 56. This is the last section of new material we're going to have. So everyone's paying attention. And we are going to look at this equation. Can anybody tell me what the difference is between this equation and the equation of an ellipse? Jack?
The other one's like y equals x, this one's x minus y.
Okay, the ellipse equation had a plus in here.
Oh, plus, yeah.
The ellipse is a plus. The hyperbola is a minus. Otherwise, they're the same. And a lot of what we do is going to be identical. Here's what I mean. Where do you think the center is?
0, 0.
Yep. And we know it's 0, 0 because there's nothing added or subtracted, right? To the x and y, I mean. Now, Maya, if this were an ellipse, what would this 9 tell me? Go 3 sideways? I'm going to do that. 1, 2, 3, 1, 2, 3. What would this 16 tell me? Up and down 4. 1, 2, 3, 4, 1, 2, 3, 4. Now, if this were an ellipse, we would take those 4 points and draw an oval through them, right? This is not an ellipse. So instead of drawing an oval through those points, I'm going to draw a rectangle. A rectangle. So I count over 3, up and down 4, and instead of connecting them with an oval, I'm going to connect them with a rectangle.
What?
Katie?
Sorry, that was my fault.
All right. I'm going to say this one more time. We already know the centers of the origin. The 9 tells me sideways 3. The 16 tells me up and down 4, just like before. Except, before I would connect those with an oval. Now I'm going to draw a rectangle through those 4 points. The reason I drew a rectangle through those 4 points is so that I could put in my diagonals. So I'm going to draw in the diagonals of that box. Those diagonals are the asymptotes of the hyperbola. You have a choice. You're either going to draw a hyperbola that opens up and down. So I'm going to sketch it. Please don't draw this. Please don't draw it. I could draw that hyperbola. Or I could draw this hyperbola, right? It's one or the other. I have the framework all set up. Now I have to decide which one it is. I'm going to tell you. Listen. Whatever letter is first in the equation. This equation is x squared minus y squared. It could be y squared minus x squared. Whatever letter comes first, that's the direction you open. So since x comes first, this is an x squared hyperbola. So I draw it on the x direction, sideways. This part isn't here. Now, why is that important to know? Because these 2 points are the vertices. There are 2 vertices, and because the ellipse opens this way, those 2 points are it. If it had opened up and down, these would be the vertices. So what are my vertices? Negative 3, 0, and 3, 0. Tyler?
I have a couple questions. Why did you draw X through the X?
Those are the asymptotes of the hyperbola, and they frame the picture. So the curve is going to be guided by these purple lines. It's going to be like those are going to be like the container that's holding the hyperbola.
Okay, and then,
All right, we're going to do more. Let's just see if we can hang in here. Now, this axis that joins the vertices is called the transverse axis. You will not forget this because the word transverse contains part of the word of vertices. These are your vertices. So what is the length of the transverse axis? 6. This axis right here, and the picture's getting kind of convoluted, but this axis right here, which is the other dimension of the box, this was the width of the box, this was the other one, that axis is called the conjugate axis, and it is 8. The only use of the conjugate axis is to build the box. And like Tyler asked, we build the box so that we can draw in the diagonals, which are the asymptotes or the container that holds the hyperbola.
Is the transverse always x?
No, the transverse is wherever the vertices are. So if we had hyperbola that opened like this, which is possible, this would be the transverse axis.
And the conjugate's always the opposite.
What?
And
Yes.
the conjugate's always the
Yes.
opposite.
All right. The only thing, we have 2 things left. We have to find the foci. Now, remember, this is my curve. The foci would be here. Please notice, it's just like with the parabola, they're inside the curve. And just like with everything else, we need to know the distance from the center. Julia and Katie. Center to focus. All right, stop and think about the quiz you just took. How did you find the center to the focus in the ellipse? You subtracted the denominators and took the square root. In a hyperbola, you add the denominators and take the square root. So, I will add these 2 numbers. 9 plus 16 is 25, and the square root of 25 is 5. So I'm going to start at my center and go forward 5 and backward 5. How did I get 5 again? I added the denominators and took the square root. So if I add 5, what do I get? 5 comma 0. And if I subtract 5, negative 5 comma 0. Now I'm going to say something here because I have graded hundreds and hundreds of papers. And many times, kids take the 5 and they go forward and backward from this point. No, this is always center to focus. Whether it's an ellipse or a hyperbola, it's center to focus. So you start at your center and add and subtract 5. Okay? Now the last piece of this is, what are the equations of these purple lines? Y equals something. right? We're shooting for y equals mx plus b. There's two of them. Let's look at this one first. What's the slope of that purple line? Can you figure it out?
1.
No.
Oh, wait.
How far up did we count? How far over did we count? So what's the slope?
4/3.
4/3. So you have a slope of 4/3. What about this purple line? What will its slope be? Negative 4/3. One will always be positive and one will always be negative. Because you're counting opposite ways. What is the one surefire point that you know both lines contain? 0, 0. The center, which happens to be 0, 0. Do you remember how to write the equation of a line? What do we do with y equals mx plus b?
Oh, 1 minus.
We plug in this is our x and our y, right?
Yeah.
And that's our x.
Yeah.
So 0 equals 4/3 times 0 plus b
B equals 0.
equals 0.
So y equals 4/3 x.
So y equals 4/3 x. You're exactly right, Ethan, plus 0 if you want to do that on the end.
Y equals negative 4/3 x.
And then this one will be the same, except the slope is negative. So b is again 0, so Ethan, you're right. That one is negative 4/3 x. Y equals negative 4/3 x. Yeah, oh yeah, you gotta write them both. There's always two asymptotes because there's two diagonals to the box, and you have to write them both. All right, let's do one more, and then we will stop for the day and let you do whatever it is you need to do. Some of you look like zombies.
When are we done learning Precal?
Well,
Never.
ideally, you'll never be done, but this is the last new thing.
This is the last
This
thing,
is the last new thing, yeah.
and then we're done.
Can you say that was that?
So what are we doing class for the rest of the meeting?
Well, tomorrow we have to finish the hyperbola, then we have to quiz, and then we'll do some review to get ready for.
Miss Ford. That's not this quiz. Can we use multiple colors?
Oh, absolutely, you can use multiple colors. You can use graph paper, you can use whatever you need. But it's bring your own stuff. Oh, I was gonna make you some graph paper, wasn't I? Okay, let's try this one. Let's see if we can get it done before the bell rings. Here we go. Where is the center? 0, 0. And we know the center is at 0, 0 because we're not adding and subtracting anything. If you look at the next problem, you'll see that center won't be at 0, 0, right? Okay, but this one is. What's that 25, tell me? Up and down 5. Why is it up and down? Because it's under y. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. What does this tell me? Left and right 2. Now, what do I do with that? Draw a box, a rectangle. It doesn't have to be perfect, just do your best. What do you do once you have the box drawn? You draw the diagonals of the box, which are now the asymptotes of the hyperbola. They're the frame that holds the hyperbola. Now you need to decide if you're going to draw the up and down hyperbola or the sideways hyperbola.
Up and down.
Why is it the up and down one?
Y's first.
Because y comes first. You were listening. Good. So you start on the edge of the box and you draw it up like this. So these two black points are the vertices. What are they? What are their coordinates? 0, -5, and 0, 5. Now, because those are the vertices, this is your transverse axis. How long is your transverse axis? 10. Transverse vertices. This is your conjugate axis, the other dimension of the box. See how this is the length of the box? The width of the box is your conjugate axis, and it is 4. Katie, what are you doing on that
I
iPad?
have my notes up.
Okay,
I don't
as long as it's your math notes.
Yes.
Now, inside the curve are your foci. We need to find how far it is from the center to the focus. How do we do that? We add our denominator, so it's going to be root 29. So we start at the center and go up root 29. So this point will have what coordinates? 0, comma, root 29, yep. And this one will be 0, comma, negative root 29. Perfect. Now we need the equations of the asymptotes. So let's look at this and see if we can figure out what the slopes are going to be. 5 over 2 and negative 5 over 2. When you built the box, you counted up 5 and over 2. That's your slope. What point, we're going to do y equals mx plus b here in a minute.
0,
What point do our lines contain?
0, 0.
0, 0. So 0 equals 5 halves times 0 plus b, so b is 0. Y equals 5 halves x. Now tomorrow, they're not going to be this easy because our center is going to be moved.
Oh no. Whoa, no.
Sorry. We are in big people school now.
So when we take a quiz over this, you're gonna be asking for, what, can you list off all the things you're gonna be asking?
Yep, I'm going to add the center, the vertices, the length of the transverse and the conjugate, the foci, and the equations of the asymptotes. You have an assignment tonight to practice a couple of hyperbolas. We'll continue this tomorrow, and I think our quiz will be Wednesday over the hyperbola. Yep, over the hyperbola. I gotta wait till I put the picture together. Abby, can you turn us off here, please?
We're gonna go.
Okay, wait, folks, sit down.